I'll walk through from lab 3, which covers CRC, stop, wait, ARQ, and Wireshark analysis. In the task 1, I created a polynomial data using the exponents taken from our student ID and use the divisor. Then I perform the polynomial long division to find the CRC remainder. And finally, I show the complete binary result, which includes both data word and CRC bits. Just there. Now we'll go to task 2. We'll explain the task 2, which is the stop and wait ARQ simulation. Because my first student ID was odd, the rule in the lab says to block 3 is lost, and ACK, but block 4 is lost. Here is the block 1. First sender transmits block 1, then the receiver gets block 1 correctly and return to the ACK1. The sender receives the acknowledgement and continues to the block 2. Next, the block 2 is sent normally. The receiver and receives it sends back to ACK2. The sender receives it, and so everything is still normal. When the sender when sending block 3, the frame is lost on the way. Because the receiver never gets block 3, it does not send any ASIC, so it's lost. Now we now the sender waits for its 5 millisecond timeout. Since no ACK arrives, the sender retransmits block 3. Now the retransmitted block reaches the receiver correctly. The receiver starts it and sends to ACK3. This time the sender receives the ACK and moves on the block 4. So the block 4 is sent and received correctly by the receiver, but the ACK for the block 4 is lost on the way back. The sender does not receive ACK4 and reaches another timer. So again, he has to wait for 5 milliseconds. The sender retransmits block 4. The receiver sees the retransmitted block 4, but it's already delivered that block earlier. So the receiver discards the duplicate but still sends ACK4 again. This time the sender receives ACK4 and continues. Sender retransmits the block 4. The receiver sees the retransmitted block 4, but it's already delivered that block earlier. So the discards the duplicate but still sends ACK4 again. This time the sender receives ACK4 and continues. Finally, the block 5 is sent normally, received normally, and acknowledged normally. After block 5, the file transfer is complete. So at the last, since my student ID is odd, block 3 was lost, and the ACK for block 4 was lost. My diagram shows the times out, the transmissions, and how the receiver discards duplicates, which is exactly how stop and wait ARQ works. Now we'll move to the part 2. Part 2, first I solve the Wireshark and go through all the tutorials and how to use it. So in this part, I captured ICMP packets between my PC and another device on the same LAN. First, I use ipconfig all to find my PC's IP and MAC address, and I included the screenshot as prepared for the cloud. Then I opened the Wireshark, selected by active interface, and applied the filter ICMP. And I pinged the second device, and Wireshark captured to echo request and echo reply, which is there. I also included the screenshots of the ping and transit results. This part helped me to understand how ICMP packets are transmitted inside the Ethernet frame. Now we'll move to the part 3. In this section, I examined the header fields inside the Ethernet 2 frame using the ARP request reply and captured in Wireshark. I analyzed the destination MAC address, source MAC address, frame type, and encapsulated data. I explained why the ARP request uses the broadcast address FF dot and how ARP helps my PC discover the MAC address of the destination before sending a ping. I also identified OUI first three octets and the NIC serial number and wrote them in the lab report. So in the part 4, I ping my default gateway, analyze the ICMP packets. I captured the first echo request in Wireshark and explained the Ethernet IPv4 and ICMP layers. I identified my PC's MAC address, my default gateway's MAC address, the source and destination of IPv4 addresses, and the ICMP message details, including the data payload that spells I. Then I checked the echo reply and confirmed that the source destination MAC address was swapped because of the gateway was responding to my PC. I also explained how the MAC address is obtained using ARP. So in the final part, I pinged Yahoo, Cisco, and Google. I recorded their IP addresses and checked the captured packets in Wireshark, where I put all the files for. One important observation was that even though the destination IP addresses are different, the destination MAC address stays the same. This is because all the packets leaving my LAN and are sent to my router, and Wireshark can only see MAC addresses inside the local network. A router replaces the MAC address at every hop on Wireshark, never sees the actual MAC of the report servers. This is the major difference between local and report capture.